Let's do number 7 from section 4.2. Okay, so here is matrix A. And here's W. And it says determine if W is in the column space of A. And the second part says is W in the null space of A. So it looks like a two-parter. So here's question 1. Is W in the column space of A? Okay. Well, again, we've seen this kind of stuff before. Just remember, if W is in the column space of A, that means it is a linear combination of these columns. All right? So that means it would have to satisfy this equation for numbers x1, x2, and x3. You don't really have to write this step every time. I just want to kind of remind you. But there would have to exist some x1, x2, and x3 that satisfies this equation for W to be in the column space. But remember, that's the same thing as a system of equations. This is the augmented matrix for the system. All right. So really, we just have to see if there's a solution to this thing. And since we already know how to do it the hard way, I'm just going to use a calculator to put this in reduced echelon form. Okay, so remember on the calculator, you always have to enter the matrix first, give it a name. So go to matrix, which is right above the x to the -1 key. When you enter a matrix, remember, choose edit. I usually like to call it A every time. But it looks like this one is a 3x4. You have to put in the size of the matrix. And now the entries. So now we'll quit. We'll escape out of there. So now go back to matrix, but this time scroll over to math and choose reduced row echelon form, which is B. We'll choose that, and then we'll go back to matrix and choose matrix A under names. And it'll give it to us in reduced row echelon form, and here it is. All right. So how are we going to interpret this? Well, it looks to me like we just have two pivot rows. So two basic variables. And it looks like we just have one free variable, x3. Okay. So let's let's characterize the system. And by the way, I guess we can stop right there because really the question is determine if W is in the column space of A, and the answer is yes. We don't really even need to characterize the solution set. You can see that we're not getting a row with all zeros where the last entry is non-zero, so we're not going to get a contradiction. So this does have a solution. Let's do part B. And And remember, part B says, is W in the columns null space of A? That's the second question. Okay. That's actually a lot easier to answer, because remember, that just means if you multiply matrix A and W together, do you get the zero vector? So that's much easier to answer. They're really asking us if this is true, just by definition of the null space. So I don't know. Let's see. So use matrix multiplication. Remember, it's row times column. And I might even need a calculator. Let's see. Negative 24 plus 2 is negative 22 plus 22. So far, so good. Second row, 24 minus 6, that's 18 minus 18. So far, so good. 12 plus 0 minus 12, it is in the null space. So it is possible for a vector to be in both the column space and the null space of a matrix.